Alright, so like the board says, map was updated, but if you made it down to that, then you should have read step 1, which it looks like some of us didn't. So Jimmy, could you read step 1 for me?
Graph paper and graph paper.
Oh, pencil and graph paper. So if you don't have pencil and graph paper, you need pencil and graph paper for today. Graph paper lives back there. Pencils live next to the fridge where the pencil sharpener is. Yeah, how do you say pencil in Spanish? Lapis. How do you say paper?
Papel.
Papel.
I say graph. Papel.
Ooh, you might need to look that one up.
It might be
I'm
like
not
graph.
Yeah,
Yeah,
can I
something
go?
like that. It's definitely like
It's a cognate.
English. Graph.
Alright, so at the end of class, well, so here's my question. When we last checked con in class, did we do it during your guys' class or the afternoon class?
What? We did it or and we made it up like 2 rings.
Yeah, like when we checked for who won, like who won the competition, like did we?
We didn't check on Friday.
Okay, so we wind up because we ran out of time in form. So we can check at the end of this class, assuming there's time. But if we run out of time, because I'm waiting for you guys, I'm gonna check this afternoon. Because no offense, but I normally have to wait for that class less. I think it's because they've gotten tired through the day. I don't know that it's like you guys are meaning to like talk too much or whatever else. But that is a goal that we can set for ourselves, right? To be efficient. So like when we put a problem on the board, let's try to do that problem, and then you have that side conversation you want to have. Not have that side conversation until we correct you, right? Because some of us are falling into some habits. Later this week. I don't know if we'll get to Jenga this chapter or not. We normally do before we take the unit test, but we couldn't take the quiz last week because a lot of us were behind on our homework. Actually, all of us except for one of us, right? So if we don't Jenga this chapter, sorry, but like I have a schedule I need to keep. I gave up that day to let you guys work on practice, and still when I updated practice on Sunday, some of us not so great. Some of us might be ineligible, and this is our first week with esports. You have a week of being ineligible to fix it, then you actually get pulled out of your sport. So be aware that if you are in esports or an actual sport, if you are ineligible, you have a week to fix it before you actually get pulled out of that activity. Alright, so the first thing if I was you that I would write on my paper is proportions. That means I should see pencils moving. Because what we're talking about now, and what we've really been talking about, is proportions. Can anyone tell me, and yeah, you can read what's on the board, but what do you think when you hear the word proportion or proportional? Jackson? Yeah, we have equivalent ratios. Now, that's a very mathy way of saying it, right? Lakin, do you have another way to say it? Ooh, things going up at the same rate. Ooh, constant rate. Tom, do you have another? Do you want to throw more in there? So if you would like to write down a quick definition, this is what it means. Hey, Elias and Jimmy, you're both about to get moved because the action's up here and you look like the action's back there at your table. So fix it, or we'll fix it for you. So you might want to write down a quality of ratios, or just give yourself an example of a ratio equal to another ratio. And we don't have to use numbers yet, but I'm going to give you numbers in just a second. So let's imagine that we're talking about, I don't know, like a pizza. If you have half of a pizza left, one half, right? If you have half of a pizza left, does that mean that your pizza was only ever 2 slices and you have one of it left? Like, so imagine your pizza, right? Anyone get pizza over the weekend? I did on Friday. I love pizza. If I've not confessed this to your class yet, love pizza. It's up there with my favorite foods. Tacos is a competition. But, so, what would your pizza probably look like? When you get pizza, how much, if you have half of it left, all the hands that I've already called on, like Josh, when you order pizza, how many slices is normally in a pizza?
12 maybe?
Sure. If there's 12 slices in your pizza and you have half of it left, how many slices do you actually have?
6.
6! This is a proportion. Proportional pizza, if you
Yes.
Jackson?
Yes.
If you could look, when I heard the half pizza, I was thinking like one half, you ate half the pizza at once.
Yeah, so I mean, if we imagine a pizza, right, half of it is gone and half of it still remains, or maybe half of it was your toppings, half of it was somebody else. You're good, Liam. Go ahead.
I just thought that you ate, like when you were talking about that, you ate one half the pizza at
So-
once.
Here's an example, and I should have cut this image. So, by the way, I should have cut this right across here to make it look like two separate images. Here's our half pizza. What are other options that we could have for our half pizza? Well, what if it was just cut into 4 slices? I have 2 out of the 4 left. What if it had been cut into 8 slices, like pizzas I normally get from Domino's? What if it was cut into 16? What if I keep cutting and I cut into 32 slices?
That's way too many slices.
Those are some skinny slices. Well, it depends how big the pizza is.
Yeah.
Yeah.
Yeah, we talked.
Big family, bro. Or if you're making lemonade, right? If you're running a lemonade stand and you're saying, well, if this is the recipe for like 1 batch of lemonade, how do I make 2 batches or 3 batches or 4 or 10 or 20? We keep scaling up because, like Lakin and people said, we're like going up at the same rate, right? We have this shared relationship. So, true story. I'm heading to SC, South Carolina this week. I will not be here Thursday, Friday. Mr. Manning will be my guest teacher. He's in for Mrs. Denies today. Like we've told you guys, we like him and we try to get him here as much as possible. Also because it gives you guys some consistency as someone you know. So please be cool for him. So Sonny, our new puppy, needs 4 cups of food per day. So we set this up per. Now I put each day. I should have really made this per. What did we say last week? Per tells us. I don't even want to finish that sentence, Tommy. Yeah, we know it means like for every, but we talked about it indicates like an operation, like a math operation. Do you remember,
No.
Caroline? It can mean multiplication. It can also mean, because they're kind of the same. Shout it out. It can mean multiplication or division, right? So here means somebody, some vet did the math, they did the division, and they figured out 4 cups each day. They did the division. And we go to set this up, we could write, and you should write on your paper, 4 cups for every 1 day. And we want to include these labels because proportions are often being used to deal with 2 different labels in a situation. So I want you to turn to your neighbor, try to work through this problem. Where would we put this other piece of info? What's the other piece of info? Who can tell me what the other piece of info up here is? Lakin? We already wrote that down. Ooh, 5 days. Here's the other piece of info that we need. So talk to your neighbor. Where would 5 days go? How would we get there? How much food do I need to leave for Sonny? Talk to your partner. Try to figure this out. Well, should we put 1 here? And then should we also indicate how many days I regret leaving my puppy?
So 5 days.
Make sure we got a label.
No, we were puppy per 5 days. And then if you multiply 4 by 5, that would be 20. So
Okay, I thought I heard you say 25, but it's 22 for the 5 days, right?
20 cups per 5 days.
So it would still only be 4 cups for 5 days? Like, why did you still put the 4 on the bottom? So if we're building a proportion, we take the given information they tell us, the 4 cups for 1 day, perfect, can you write that down? But then if we want to find out 5 days, like if you put 5 days on this bottom, you can't put 4 cups. Because my cups need to go with the 5 days. So this answer is right, but that should go up here. Alright, now we're using random cards. So sorry if I'm calling on the same people again, but now I'm just working through the deck. Jackson, where would I put 5 days? Why on the bottom? That's where the days went. Could I flip this over and say one day I need 4 cups of food? Sure. But since we put days on bottom, we keep putting days on bottom. Liam, what did you guys do next?
You multiply 4 by 5.
Why?
To get the answer.
But why did you multiply by 5? How did you know to do that? You're telling me to do it. It's right, but how'd you know that?
Because if one day has 4 cups and 5 days without 4,
Because Liam looked at what is this multiplication, and if it happens on the bottom, I gotta do the same thing on top to keep it fair, keep it proportional. Guys, you should draw those arrows with the times 5, because this next problem is not going to be as easy. Ooh, I said that word. But this one didn't really feel tough, right? It's just kind of like whatever.
It was okay.
So wait, what was our answer here? 20 days. Or 20 days?
20 cups.
Ah, the same label we just used. It'd be 20 cups. And no, I would not leave my puppy for 20 days. It would make me sad.
That was
All right, you guys ready to help me keep planning? Guys, I try to incorporate real situations into class. So don't just think I'm having you plan my trip. My trip is all planned. So, to get to South Carolina, we're driving. Now, if you've ever driven to the Carolinas, you know it's not short, but it's not so far. Like, it's not like Texas, right? It's like 8 to 10 hours, depending on which Carolina you're trying to get to and where, whether it's North or South Carolina. So here's your information now. I want you and your partner to try to build this whole thing. I don't want to write anything. I want to see what you guys can figure out. Go for it. Make sure that we're doing the math first, and I don't mind if you draw. We got to do the math first.
When is it on? Oh, it's I just have like 8.
So let's go ahead and have it using graph paper for that class, just because I like the graded paper better. So have it keep it vertical. So from this situation, what are we told? What are we going to write down first? We will be able to use a calculator, yes, but that is not necessary before we start writing things down. What do we want to write down? What information do we have?
Okay, I think so. Approximate.
Well, Tommy's a pretty good idea. I have it right now. Now let's practice starting at the top left of our paper. Right, you already got one. So just what Tommy did. Now, Tommy, don't move on until your partner is with you, right? Because if your partner, you may use a calculator here. If you don't have one, you're gonna have to borrow one of my 5. Guys, some of my calculators are missing. If you see them around the building, please bring them back.
Everybody, what's up?
Ooh, you're squeezing your work. Give yourself some more space in here. We got plenty of graph paper. Make sure you put labels. Make sure you include your label. Now wait, does the 540 go with the 18? Does the 540 go with the 18? What'd the 18 go with? Because I like what you did, but I want, when we go to write this, I want you to rewrite this so you see the math different. What you did is fine. You're gonna get the answer. But you didn't build a proportion. Because a proportion is a fraction equal to a fraction. Great. You just straight up figured out how to get to the answer. Which you're right. Like, what you did is right, but we're practicing building a proportion. Here, I think I just straight up confused Josh, so we should come back together. If I take my given statement, how do I write this to start building a proportion? Lakin, can you help me? How do I write it? Like, what'd you put on your paper? Ooh. 18 miles I agree with, but what did that 18 miles go with? How much gas? 1 gallon. Excuse me. So you want to have a number, because I agree that per gallon, we can assume it's a 1. We don't want to assume. We want to actually put how many gallons. Now wait. What am I going to do with this 540 then? And guys, if you did this a different way, please rewrite it the way that I'm not saying erase anything, but we need to practice building the proportion. Major, what could I do with that 540? Would it go? So I hear what you're saying. You're not wrong. You're right. But if I'm trying to build a proportion, where would 540 miles go? Top or bottom here? Ooh, because miles is on top. Miles is on top. Now, as I walked around, some of you guys did this, which is absolutely what we want to do. But the reason that we want to do this, hey, this is when you want to pay attention, because this is like the meat of the lesson. We're trying to figure out how to go from 18 to 540. We're trying to figure out what multiplication takes us there. And I don't know. And since I don't know, how can I figure out multiplication? By doing division. So if I want to go from 18 to 540, what we do is 540 divided by 18. What did this get you? Anybody?
30.
30? Yes? Like straight up 30?
Yeah.
Sweet. So this is times 30. So what would also happen on bottom?
Times 30.
Times 30, which means what's our answer?
30 gallons.
30, and with a label, right? 30 gallons.
What the fuck? 30 gallons.
Questions. That's real life problem solving. So as you start to see these on your homework, you don't have like labels and word problems to deal with. Like tonight's homework, you won't see words. It's just going to be straight up solving proportions. So let's practice a few of these. Yes, some might feel E-word, but that's so that we practice a few. We want to practice write down the proportion, show what we're doing. So everyone's going to write this down first. Then you're going to talk with your teammate about how do we solve for that variable. Because the first problems on this night's homework, you don't have any word problems. Even if you know what the answer is, we want to write this. Guys, this could be your homework problem tonight. Like, I'm not joking. This is straight up one of the problems from tonight's homework. We want to think about going towards the variable. We're going this way, towards the variable. I should be able to see your answer as I come around. I should see the work. What did we do? What was that multiplication? Yes, the first one is sort of E-word. The next one definitely is not. Yeah, I love it. Circle the times 2. Got the second one down? Do we know how to go from 8 to 12? We're looking for the multiplication. We're looking for the multiplication. If we don't know the multiplication, do division. We're going to 12. Owen! Help me out with the first one there.
So what I did is
I bet you're done with the first one. Like, sorry, I heard people complaining that I'm pulling us back together. Bet you're done with the first one. Owen, sorry, go ahead.
I did like from the top.
Yeah.
I did 3 times 2 equals 6.
Yeah, Owen figured out this is a times 2. And if you want evidence of that, work it backwards. 6 divided by 3, that equals 2. And that tells us that's the times 2. So then what else did that tell you, Owen?
That you had to put James times 11 by 2 as well.
We got to times 11 by 2 as well, which means y equals what here? Boom. Nice work, Owen. Reese, help me out with the second one. Say it again, louder. You're right. So Reese didn't know exactly how to get from 8 to 12. Hey guys, some of you might be thinking it's plus 4. You cannot add in proportional situations. We have to be doing multiplication or division with these arrows. So Reese did the division, found out that was 1.5. Okay, so what'd you do with that 1.5? Ooh, careful. This way, we're multiplying. We're getting bigger. You're kind of thinking about my next problem, actually. You don't realize it, but you're on my next problem. So, what Reese said is this is times 1.5. We got bigger, right? 8 to 12 times 1.5. We do that down here as well, times 1.5. And what's that give you for the value of p then? Anyone?
13.5.
I think you're right. Yeah, 13.5. So P is 13.5. Because we did times 1.5. And guys, you can use calculators on all this stuff.
Since it's 8 over 9, the answer, you could just add 1.5 to the 12.
What? I'm confused. Say it again, slower.
You can just add 1.5 to 12 and have it on the bottom of your answer as long as you still have the 12 on top.
Add 1. I don't know what you're meaning, but I might not let you explain it because we're not supposed to be doing addition here. We're really only supposed to be doing multiplication and division. I kind of want to see what you're doing, but I want to come to you and see it. All right, so we always are working towards the variable. So, guys, I'm going to just rewrite this guy. I don't like when the variable's on the left. But, guys, with an equation, I can flip the order and it doesn't matter. So what if I rewrite this as 8/9 equal to 7 over p? Is that the same thing as what they gave me?
Yeah.
Because an equation, Jackson, how old are you? If I say Jackson is 12 years old, and then I flip it and say 12 years old is Jackson. Jackson is 12 years old. 12 years old is Jack. It's the same thing. When you're saying something's equal to something, you can flip it around and it's the same. So you could either tell your brain, I'm going this way, or if you're like me and you don't like going right to left, flip it, and now we can go this way. Right? Because we're trying to get to P. 8 to 7, though, is that getting bigger or smaller? Smaller. So what do we multiply by to get smaller? Something less than 1. If we want to get smaller, we need to go less than 1. This multiplication is going to be less than 1. See if you and your partner can figure it out. I'm going to give you 1 minute to try to figure this out. I can't tie my shoe.
Let's say times 0.
Times 0. Make sure you're writing this stuff down so you can look back at it later. How do we go from 8 to 7? So it depends on what you're asking. Like, we can still do multiplication this direction, right? From 8 to 7. But what Mrs. Fisher's answering is to figure that out, we're going to need to do a division to figure out what that is. Yeah, so that is the number you're multiplying by.
don't know how to what you can multiply going forward, times by going backwards. And then whatever number you get, you can multiply by that number. I can come over and we'll try to. So did you guys figure it out?
I didn't spot on that quickly, but you can always watch the video. Alright. This is one of the tricky kind. When we get smaller, it's weird. We are used to multiplying to get bigger. Right? That's like what we learned with multiplication. I have times 2, times 3, times 10. But we're getting smaller here. So Jackson, well, actually, I should keep using cards. I know you did it right, so I was just going to call on you. Not here today in the bathroom. Tommy, can you talk me through what we could do here?
We could take 8. We could take 7.
Ooh, guys, you might want to put a note on your paper. We are trying to go this way. We're trying to go left to right. But to figure it out, we divide it backwards. We divide backwards. We do 7 divided by 8. That got 0.875. What do I do with that 0.875, Josh?
Multiply it by 9.
I don't have to do this, but it's good to write. I could double check that that's right in my calculator, and it is. So that tells me down here, we're doing times 0.875, and what did we get for the value of P? 7.875? Sure.
Yeah, that's what it is.
See, I'm hearing some different numbers shouted out, so let's double check. 9 times 0.875. Yeah, it's 7.875, guys. Double check your calculator work. 9 times 0.875.
You really don't need to put in that 0, but.
Yeah, I mean, not in your calculator, but it is important to write because it kind of indicates, hey, make sure you pay attention. That's a decimal there. It's not 875. It's the decimal, 0.875. Questions on this one? It would have been the same if we tried to go this direction. I don't like going right to left. It feels kind of backwards to me. So I always like to set them up going left to right. Alright, so try this one with your partner. Now the variable's on top. Now the numbers that we know are on bottom. Guys, if you keep this graph paper, some of you, these might be all of the homework problems you see tonight. Because I think there's only 4 on the first assignment. If you keep this paper and pull it out when you're doing your practice, you might already have homework problems done. What's up? Yes, so that means times 10 too. That means you got a really, really big number. But that is not what we're doing right now.
Wait, God, do you see?
Wash our hands. Alright, that's what matters. So now, what we want to draw is an arrow from the 5 to the 8. Alright, so we're trying to go this way. No, wait, why'd you put, is that a 2 or a Z or what is that? So let's clean that up a little bit. Let's erase it. And let's make it really look like an N. Because if we're going to look back at this paper, we need something to actually look back at. I mean, you could also make it X. If you like using X. Sure. We normally use X. Sure, J. So how do we go from 5 to 8? Do we know how to go from 5 to 8? I'm grabbing you a calculator, Jimmy.
We already have how we got it.
Yeah, but I want him to have this own so he also practices it. And you seem like you were using that calculator. So do you know how to get from 5 to 8? Does it matter? How do we get from 5 to 8? I don't know how. Do you know how? So since we don't know how, we're going to do that. Then we're going to write that down on our work so I know that you know what you're doing because that goes with the arrow.
Okay, so let's make that note and see how to do it. Make your arrows.
What? We do math and pencils. Maybe switch pencils because that might be a crappy pencil.
Yeah, it keeps breaking.
Yeah, dude, just switch pencils. There's a jar full of them.
Fine.
All right, Mr.
This
Leach.
period.
You ready?
Wait, Leach?
You ready?
Yeah.
Because your card's back up.
Your turn, Jackson.
All right, Jackson, walk me through.
If you want how we found out what to times it by, we took 5 divided by 8, we got
Ooh.
Oh, 8 divided by 5.
I was about to say you didn't. You did 8 divided by 5 because we do the division backwards.
6.
And you got 1.6.
And then for the answer, we did
Ooh, hold on. How did you get to the answer?
we times it by 12.
Times what by 12?
1.6.
Yeah, because we're doing, really, if I was saying that, I'd say we did 12 times 1.6, but it's the same. What'd you get?
90.2.
Everyone get 19.2? Sweet. Feeling better about this? Feeling pretty good? Try this one.
I'm dead. Oh, sure.
This is not the same as what you wrote down a couple equations ago. Are we getting bigger or smaller, ask yourself.
Oh, that's easy.
Ooh, bad.
Hey,
Sorry.
You cheat, bro.
We're going from 7 to 8. We're going from 7 to 8. So we're going to go from 12 to something bigger.
I'm insane.
I have a feeling this might belong to an 8th grader, since 8th graders were in my room on Friday. Liam! I'll give you guys like another minute. Here, and if you want to see the next one that we're doing,
Mr. Hudson.
next one that we're doing. I heard my name, I'm coming. What's up?
A number of minutes.
Did I hear my name from over here or somewhere else?
I did. Mr. Hudson.
So I did this problem on purpose because it's a little gross. What? Gross is okay every now and then. Liam, what is your thought process when you look at this problem?
Disgusting.
Okay, but say more.
I don't like it.
Say more.
It's the one not that. It's terrible.
Okay, moving on. Jimmy, when you looked at this problem, and I know you know what to do because I was back there, what are you gonna do?
In my brain, it's just, so you know how we have it go 7 to 8?
Yeah?
I put 1.
So we can't add subtract. You might have been out of the room. I think you were in the restroom. We talked about we're not allowed to add subtract here. Because it wouldn't be true. So, no, I love that you said that. So think about if we added, right? If we added 1. 7, 8 adds 1, right? That's one way I could look at it. 12 to, okay, if I add 1, 13. Hey, real quick, type in your calculator 12 divided by 7. And then type in 13 divided by 8. Type in 12 divided by 7. Hit enter. Then type in 13 divided by 8 and hit enter. Because if we just added 1, those are not equal. 12 over 7 and 13 over 8 are not equal. That's why we can't add or subtract here. So, do you want to give it another shot, or do you want to pick somebody else? No, I would pick. You want to give it another shot, or you want me to move on?
Move on.
Caroline, what could we do here? Hey guys, I don't know who thinks we're in choir, but we're not. We're also not in art class. So we're listening to our classmates right now. Caroline, what could we do? Do you know how to go from 7 to 8? I don't. Do you? Yes! We can do 8 divided by 7. Now, friends, I'm trying to save you from yourself of rounding and getting answers wrong. If you round... Hey, Jimmy, I need you out of your shirt, please. I'm teaching, you're learning. We need to look like it. Also, you didn't know what to do, and I'm telling you what to do, so we should probably be paying attention to writing things down. So what I could write down on my paper is, okay, so I did 8 divided by 7, but this number goes on and on. Unless you want to write the whole number down, here's the trick. Where am I going to use that number? On top, right? To multiply by the 12. So, guys, watch this. If I, on my calculator, now just hit the multiplication button. All I did was hit multiply. See how it says ANS? Anyone know what that stands for?
It's the answer.
It's the previous answer. So it will grab that number. I don't have to type it. It just grabs that number, and now I can do times 12. Now, in Khan, it's going to tell you where to round to. It'll say go to 2 decimal places, 3 decimal places, but this is the safest way to get to our answer. We know we used the entire value. We got the most accurate answer. Then Khan would tell me to round. Right? You don't want to round halfway into the problem. It is safer to do it this way. So this one was 1.14, yada, 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 yada. This is 1.14, lots of other numbers. It was actually 2857. If I just want to show off that I have these memorized, I guess I can write that. Which means that's what we're doing in top also.
You also forgot 143.
No. I think 143 is what you rounded down to. But I do because mathematical accuracy matters, so please don't start an argument with me using a rounded number. You will lose. Is this one going left to right? This one's going right to left.
Oh.
I'm going to flip it around. You don't have to, but if you want to take my advice, you could. I'm going to flip this around and write it 4/5 first. Z over 12 seconds. And now I feel like that's easier to solve because I'm going left to right like I'm used to. We're running out of time, so I need your help. Like, we're going to have to do this live together. Except I left my cards. Lakin, do you know how to go from 5 to 12? I don't. Yeah. Ooh, well, okay, so you know how to figure it out. Lakin said, do 12 divided by 5. What's that give us? 2.4?
Wait, I put the wrong thing.
What? 12 divided by 5? I think it's 2.4. Can we get verification from somebody else? 2.4? Okay, Major, what do I do with that 2.4 now? Now we take it up top. We do times 2.4 here. And what do we get? What is it? Just 9?
No, it's 9.6.
I was about to say, I think it's going to be some kind of decimal. 9.6. Bless you. Questions on what we just practiced? All right, hold up. Do not pack up yet. I still got 2 minutes. Here's our quick review. Right? When given a proportion, when given any proportion, you could write this down if you want to. Right? Here's what we practiced. To figure out this multiplication, we did division backwards. So we did D divided by B, and that comes out to be some number. That number is what we figure out is our multiplier, or our constant of proportionality here. And we do that number multiplication on top, as long as we set our problem up the way we like it. Now, if you're going right to left, you can do the same thing, just with everything flipped around, right to left instead of left to right. Questions? We are only multiplying or dividing here. You could just multiply. Sometimes you look at it and you're like, oh, that's divide by 2. You can also look at it as multiply by a half. All right, now you can pack up and start heading out to, are you guys still connections after this? Yeah?
Here.
You did forget 143. 8 divided by 7 is 1.242857.
That's a lie. That's a lie. That 3's a lie. This keeps repeating 142857 forever. That 3 is rounded off of that 2 because the 8 says round your 2 up, but that 3 is a lie. I am telling you, like, mathematical accuracy matters. Your calculator's kind of stupid. Sorry to break your heart, but like, that 3's a lie. That's not true.